Another function that's fun to implement and also illustrates the difference between the traditional approach and the functional approach is repeat. Now, what repeat does is it takes two arguments and it, let's say A and B, and then it returns B A times. It returns a collection that contains B A times. So for example, if we were to call repeat with 2 and 3, that would return this. So in the traditional paradigm, we might implement something like repeat like this, where we say we take A and B, and then very similar to what we've done before, we would say, well, we have some result array, and then we iterate and say for let equals that I is less than A, so A serves as a sort of limit, and I++. We push onto the result B. And then at the end, we return the result array. So let's see if this works. And there you have it. Let's say we want to return 3 4 times. That works too. Now, what would this look like as a functional implementation? Well, it's very simple. We'd say A and B. Now, we're going to need some helper functions, because the first thing we want to do is we want to check if A is 0, and we're going to see why in a second. So 0 is going to be a function that returns a Boolean based on whether or not the given number is 0. So if A is 0, we want to return an empty array because we want to return B 0 times. But if A is not 0, then what we want to do is we want to construct a new array with B, and you guessed it, this is very similar to what we've been doing, the result of repeat of A minus 1 and B. And A minus 1 we can turn into another helper function. This is also a function Clojure has. So is 0, by the way, only with a question mark. So dec is the opposite of inc. It just takes a number and reduces it by 1. So now here we can say dec A instead of A minus 1. This is more idiomatic in a functional approach. And there you have it. So what does this do? Well, it takes A and B. We know we want to return a collection that contains B A times. If A is currently 0, that means we don't want any instances of B in our collection. So we just return an empty array. And if A is not 0, we say, okay, well then construct an array that contains B at the beginning, and then it contains A minus 1 more B's. That's basically how we do here. And this is very similar to our implementation of map at the beginning, for example, where here we check if a collection is empty. Now we check if A is 0. Here we construct a list using rest. And now we construct an array, I should say, in both cases. Now we construct an array using dec. And in both cases, we use recursion, like this. So that's how you would implement repeat in a functional manner. Now, what repeat can actually be used for is, for example, you could implement something as mundane as multiplication in terms of repeat. because multiplication is simply repeated addition. Now, we're not going to worry about multiplying decimals or negative numbers here. We're going to assume that we're only given positive integers. But what you get then is a very simple implementation and a very, very idiomatic implementation in the functional approach of multiplication, where you would say, well, we're simply going to repeat we're going to repeat b a times. And then what we're going to do is reduce plus over that. And that should implement multiplication. Let's see if it works. And there you have it.